You need an inverted fluorescent microscope, preferably with phase contrast and with a filter block for lucifer yellow. Under phased contrast, look for the edge of the electroporated area. You will see two lines. Under fluorescence, cells on half of the slide will be fluorescing intensely. The line closest to the glowing cells is the edge of the electroporated area. Any fluorescence beyond that is due to the transfer of lucifer yellow through gap junctions. For example, this image of epithelial cells shows cells that have been electroporated on the left side of the image, transferring lucifer yellow to neighboring non-electroporated cells, creating a gradient of glowing cells from the edge of the conductive coating toward the right. This image shows the same frame of cells under phase contrast. Note that you can see the etched line very clearly. A quantitative measure of how much gap junctional transfer has occurred can be done manually by working with the fluorescent and phase contrast images of electroporated cells. The stars along the edge of the conductive area are considered donor cells. They have been electroporated and taken up lucifer yellow. They pass lucifer yellow to neighboring cells to the right, which pass it on still further in diminishing amounts. The ratio of the dots to stars, 41 to 8 in this case, can produce a number for comparing how extensive gap junctional transfer is. In this case, 5.1 is the gap junction index. An alternative to manually marking and counting cells is to use image analysis software to measure the relative amounts of glowing along the non-electroporated side of an electroporated cell border. These cells do not have gap junctions. Here is the right edge of the electroporated area. Note there is no gradient of fluorescence, which indicates the absence of gap junctions. Under phase contrast, you can clearly see all the cells. Note that the etched line is also clearly visible. In this example, all of the cells in the chamber were stimulated with epidermal growth factor, EGF, and 10 minutes later fixed and probed for phospho-ERK. Note that the stained cells on the right have not been electroporated, and the cells on the left, up to this line, have been electroporated. The non-electroporated cells show brown staining with a phospho-ERK antibody and immunoperoxidase. The electroporated cells show no staining as the electroporated phosphopeptide has blocked the SH2 domain of GRB2 and inhibited ERK phosphorylation of EGF. Note the region of 3 to 4 cell lengths to the right of the line, where cells were not electroporated yet do not show staining. These are cells that have acquired blocking peptide from their electroporated neighbors via gap junctions. This is the most powerful demonstration possible that the inhibition of the signal must be due to the peptide and cannot be an artifact of electroporation, since these cells are not electroporated. This is the same frame shown under phase contrast. Note the absence of any change in morphology after electroporation. For further details regarding how to obtain optimal electroporation, please refer to the hard copy manual or the InSitu Electroporation section of the Cell Project's website. You will find a number of helpful resources there, and you are always welcome to contact Cell Projects with any questions.